Yes, class. Am I audible to all of you? Khadija, Leena, Humaid, Nuha. Humaid, you were absent in the last class as well. C class, I think it wasn't announced, so today I won't take that class. 8 to 9, that is after this class, on Tuesday, Thursday, and Saturday. 3 days for 1 hour. You'll be having your classes for thermal physics, thermal properties of matter, kinetic theory, thermodynamics. That will be dealt in that batch. All right.
Ma'am,
That's
8 to
why are
9
we doing
p.m.
that? Yes, Umaid, 8 to 9 p.m. IST.
Okay.
Means when this class ends, then only. So I'll end this class a little before, 5 to 10 minutes before, so that at least you all will at least get 10 minutes break. Okay. So 1 hour class will be there on Tuesday, Thursday, and Saturday. Please note down the days because from this Saturday we'll start it. I wanted to start it with today. It's started from today, but the issue was that I didn't inform any one of you. I couldn't discuss that with you. So that's why from Saturday we'll start those classes. So make a separate notebook for thermal physics. We'll be dealing thermal physics only there. Well, am I audible now? I think now it would be fine. Now the connectivity issues would be better. Okay, so on these 3 days, Tuesday, Thursday, and Saturday, we'll be having the extra classes. So in this batch, your regular C gravitation is almost towards the end. Gravitation will be completed mostly by today or by the next class. And then we'll start with solids. It's also a small lesson. And then we'll be doing fluids. That will take a lot of time. So that it doesn't stop our syllabus, we'll be discussing thermal physics separately. Yes, class. So in the last class, we had discussed the gravitation potential energy. So I told you that it is basically the work done. And we also obtained the formula. So through the help of this question, let us revise it. So one mass is given as 2 kg, second mass is given as 3 kg, and they are separated by a separation of 10 meters. So this is equal to minus G m1 m2 by r. All right, this was the formula which we had seen. Minus G, gravitational constant, 6.67 into 10 to the power minus 11. Mass 1, 2, mass 2, 3 kg. Separation is 10. So this is around minus 37 into 10 to the power minus 12 joules. This much of energy. Second one, work done to make the system. So what did I tell you? Work done whenever you have to calculate to make the system, it is exactly equal to potential energy. So this will also be minus 37 into 10 to the power minus 12 joules. Third part says work done to break the energy, break the system. Work done to break the system. Always remember it is negative of U. So minus 37 into 10 to the power minus 12. This will give you plus 37 into 10 to the power minus 12 joules. So mainly you have to remember that the formula for potential energy, which we studied yesterday, was minus GMM by R. Minus sign we will not be using very much in the theoretical questions. But since this was a numerical, we have used it. Write it. One more question we'll see. Yes, class. Any answer? 5 minutes I have given you for this question. See, firstly, whenever we discuss potential energy of the system, you have to understand that we have to count the number of interactions. A number of interaction means how many masses will be able to exert potential energy on each other. All right. Now see, if I tell you these are 4-point masses which are placed on the corner of a square, correct? Now, if I ask you how many potential energies will be there in the system, what will your answer be? I'm not asking the answer, final answer. Number of potential energies, like between M and 2M, there will be one energy. Like this, how many energies? All of you answer me in the chat column. I'll discuss it. I'll discuss the entire solution. Mariam has answered. Nuha has answered. Others also. Humaid has answered. At least just let me know what you all think. I'll I'll discuss it everything on my own. Don't worry. But at least answer whatever you think. Like M, this I am giving you an example. M and 2M, they'll be having one potential energy between them. So this is like this. How many number of potential energies in the system will you see? Only M to M, 3, 2, 4. What do you think? Humaid, Nuha, and I think Mariam. These three have only answered. Khadija, Leena, what do you think? Khadija and Leena? See, all those who are saying 4, you have calculated in this manner. Between M and 2M, it's 1. 2M and 3M, it's second energy. 3M and 4M, it's third energy. Between 4M and M, this is the fourth energy. Correct? These are the 4 potential energies you are answering. Class, one more thing. M and 3M will also be interacting, no? And this 4M and 2M will also be interacting with each other. So 5 and 6. Clear? Because these two will also be interacting. They'll also be exerting potential energy on each other. This is the potential energy of the system, not one single particle, right? So 5, 6 potential energies. That's why I wanted to ask, because most of the students answer this number 4 only by seeing the outer one. These diagonal placed masses will also be exerting forces on each other. Therefore, you will have potential energy of this also. Now see, one by one, let us put the value of all. First, let us put them. What is the general formula? I am writing it here. G M1, or minus sign also will come. So let us write it as complete formula. See, the formula is minus G M1 into M2 divided by R. Now between the first one, minus G, first mass is M, multiplied to second mass is 2M. What is their separation? A. Is it same? Minus G, M1 into M2 divided by R. R means the separation. Second one is this. So minus G, first mass is 2M, second mass is 3M. Their separation A. Third one, minus G, 4M into 3M, separation A. Fourth one, minus G, M into 4M by A. Then fifth one. Now look, in the fifth one, the problem is that this we don't know. But we can calculate. See, if this is A, this is A, this is forming a right angle triangle. Look here. These two sides, they are forming a right angle triangle. This one and this one, they are forming right angle triangle. See, if this is A, this is A. So hypotenuse will be under root A square plus A square, that is A root 2. Similarly, this will also be A root 2. So both the diagonals will be A root 2. We want to find out the diagonal. So this is a triangle. This is how we get the diagonal. Understood how it's A root 2? It's like this is one triangle, A side, this is the hypotenuse. So hypotenuse is equal to under root a square plus a square. 2a square, which is equal to a root 2. Like this we have obtained. All right, somewhere on the corner if you want, you can write it down. Otherwise, you'll be able to remember it. So now we have this separation also a root 2. So minus g m into 3m. See, this is m, this is 3m. Separation is a root 2. Now minus g, this is 2m into 4m separated by a root 2. This is your answer. You just have to simplify. For the simplification purpose, now it's best if you take minus g m square by a common. Minus g m square by a. Now see what is left from here. 2. Correct. From here, 2 into 3, that is 6. From here, 4 into 3. So plus 12. Then from here, plus 4. From here only this 3 by root 2 because a has already been taken common. So plus 3 by root 2. Plus from here 2 into 4 is 8. 8 by root 2. Correct. So final answer is minus g m square by a. This becomes 24 plus 8 plus 3. This is 11 by root 2 joules. Fine. Write it down. This is clear to you why it won't be just the 4 of them. It will be all of them will be included here. Write it down. Whichever part you have not understood, let me know. I'll explain it again in between. Now class, that was potential energy at a particular point. If we have to find out the difference, like this is initial point, this is the final point. Fine. Earlier this point wasn't there. This was taken as infinity. Remember, R1 was taken infinity in the entire derivation. So here also in the derivation, you won't be having a very different step. See, minus this gmm by x square dx, integrating it from infinity to R2 was there. Now it will be R1 to R2. So just the limits will be, just the changes are going to be there in the limits. Because instead of infinity, R1 is there. 1 by infinity was 0, so many things got reduced. Whenever you're taking potential energy difference, it won't be only having one single value of R. So see, G M M is taken common, integration of x to the power minus 2 dx, R1 to R2. Now G capital M small m, this becomes minus 2 plus 1 divided by minus 2 plus 1 from R1 to R2. Let me write this properly. I hope you all are thorough with the integration. In the last class also I've repeated a number of times. All those who want an extra class for calculus or are weak with integration, differentiation or vectors, do let me know so that extra classes can be arranged for the same. If you are fine with all this, then it's okay, because only this much of calculus will be used in your class 11. So see, this becomes minus g m m x to the power minus 1. This is R1 to R2. So minus g m m 1 by x, limits from R1 to R2. I've brought this x to the power minus 1 in the denominator. Now look, so final formula that we are getting is of potential energy. The final formula that we are getting is minus G capital M into small m divided by R was just there. Now it will be 1 by R2 minus 1 by R1. This is the difference that will be coming. And both the derivations are also same. If you look at the derivation, both these derivations are also the same. Fine. This is the initial separation. And this is the final separation. Fine. Write it down. Then a very small topic is there, gravitation potential. This I'll discuss. Quickly write this down. This derivation is easy now. You have done it once. See, gravitational potential is a very small topic. It's easy to remember. And as I've already told you that similar things will be there in electrostatics also. So again, electrostatics will also be having electrostatic potential and everything. So keep all these topics in your mind. Okay. So gravitation potential, no, the same thing which you have studied. It's just that this is the scalar form. In vector form, you have gravitational field. In scalar form, you have gravitation potential. Rest of the thing is same. See, suppose I have a unit mass. Let's say its mass, this is 1 unit. Fine. So it is the work done in carrying unit mass from infinity to point against the gravitational field. Same thing. But what you have to remember that this is a scalar quantity. This is the very important. Now look here. Potential is represented as V. So potential at point P in carrying or the work done in bringing a unit mass from infinity to a point P, bringing a unit mass, so work done per unit mass, this is known as potential. If I put the value of M as 1 kg, if M is equal to 1 kg, so potential is equal to work done from infinity to that particular point. So its potential is what? It's basically the work done to carry a mass, a unit positive test mass from infinity to a point. So SI unit will be, see, work done, this is joules, mass is kg. So scalar quantity with SI unit joules per kg. Fine. These are some quantities whose potential you have to remember the way you have remembered, no, the values of solid sphere, hollow sphere also in the last class for gravitational field. Similarly, remember it for potential also. This is not very important class, but some of these, it can come in your exam. See, for a point mass, it will be GMM by R. Why GMM by R? Because see, work done is G, capital M, small m by R. And this is again per unit mass. Mass will be cancelled. All right. That's why we write it minus gm by r. And if it's a difference, it would be 1 by r2 minus 1 by r1. In your syllabus, you don't have these two derivations. You just have their formula and numerical, application-based numerical. Now, if you have a hollow sphere, again, there will be 1 point outside. There will be 1 point on its surface and 1 point inside. So outside, it will be the same, minus gm by r. At the surface or inside any point you take, it will be minus gm by capital R, means radius. This is the separation, this is the radius. And this is one very important formula, not important from examination perspective, but just in case if this formula comes in the exam, if you know, the question will be very easy. At the center, here at the center, gravitational potential will be minus 3 gm by 2r. Minus 3 gm by 2r. Okay, now if it's solid, so outside and surface will be the same. See, inside will be different. Inside is minus gm into 3 capital R square minus small r square divided by 2r cube. Just remember all these formula. Do not go and learn from any reference book their derivation, because they also have individual derivations. Nobody will ask you these derivations. Formula can be asked maximum, so prepare for that. Formula based questions will be there. These you have to remember, but do not waste your time in memorizing the entire derivation. That's why I have already written these formula for you, so that we also don't waste our time in the class. And there's a relation between center and surface. See, gm by r, gm by r. So V center is minus 3 by 2 of surface. Not even minus, minus will be included. 3 by 2 of the surface. Next topic is escape velocity. That is very important, but gravitational potential, write it down. Look, class, the next topic is escape velocity. So escape velocity and orbital velocity, these two velocities you will be having. First, let us discuss what is meant by escape velocity. See, there's a gravitation pull of Earth. The forces around the Earth, these are continuously, see, this is the gravitational field of the Earth, where gravitational force is being exerted. So if I say within this sphere, gravitational force is being exerted. Within this sphere, gravitational force is being exerted. Fine. So what happens is that this mass M, let's say this is some body which is kept on Earth. Now, in order to make it go up, it will work against it, but it will come back down because of gravitational pull. You want that this goes to infinity and does not return to Earth back. So for that, it has to escape the gravitational pull of Earth, the gravitational force, that minimum velocity which is required so that it can escape this. It can cross this border, it can cross this threshold and escape the gravitational pull of Earth. That velocity, minimum velocity, is known as escape velocity. Let's say when the velocity is 5 meter per second, here, 5 meter per second, the body is still here. When it is, as soon as this is becoming 6 meter per second, it is able to go cross it and reach up to infinity. Now 6 will be the escape velocity. Now 6, 7, 8, 9, 10, whatever velocities will come, those will be the velocities, but that won't be the escape velocity. Escape velocity is just the minimum velocity, the first velocity that comes. Fine. And for Earth, body will stop at infinity, and velocity, escape velocity of Earth is 11.2 kilometer per second. All right, this is 11.2 kilometer per second. Now, if you want to calculate gravitation, this, see, Earth is there, one mass is there, this is taken up to infinity, the same mass is taken to infinity. So what happens? Basically, the entire potential, this kinetic energy becomes equal to, at a certain height, this will be equal to the potential energy. Let's say the separation is R. G capital M small m by R. This is the escape velocity. Mass will be cancelled. What is the value of escape velocity? 2 G M by R. So value is under root 2 G M by R. 2 Gm by R. Now see, if I want to substitute it in terms of acceleration due to gravity, acceleration due to gravity is Gm by R square. See, let's cross multiply. This will become Gr square is equal to G into M. Now see, if you put in the value of Gm from here, you have no the velocity as under root 2 Gm by R. I am saying instead of this Gm, I can put Gr square also. So escape velocity is equal to under root 2. This is Gr square and one R was already there in the denominator. So R will cancel this R. Escape velocity in terms of acceleration due to gravity is 2 G capital R. But do not rely only on this. This formula is also used everywhere. Under root 2 Gm by R. So it is independent. You can see this is independent of mass of body. This is just the mass of Earth. This is the radius of Earth. So this is not depending upon the mass of body. It is just depending upon this mass of the planet on which it is. If it's Earth, this will be mass of Earth. If it's Jupiter, it will be mass of Jupiter. And when you substitute all the values, no, here, when you will substitute all the values, G, you will take it as 9.8 meter per second square from here. Then then radius of Earth 2, you will get the value exactly as 11.2 kilometer per second. This is the entire concept of escape velocity. Easy, not difficult. Escape velocity and orbital velocity both are very easy. Definition is that this is the minimum velocity which is required by the body so that it can go to infinity and not return back to Earth. It can escape the gravitational pull of Earth. Value at the surface of Earth is 11.2 kilometer. And just this small, very small, minute derivation where kinetic energy becomes equal to potential energy. Write it down. Some questions we'll see on this. just note down this question, because questions I'll do all together, all the questions of escape velocity. Orbital velocity is left, Kepler's law. Escape velocity's questions, orbital velocity, and Kepler's laws are discussed. So that I'll take one more class. Tuesday we'll complete it. But see, class 8 to 9, now you'll be having your extra classes from Saturday. Okay, so make a separate notebook for it. All right, if you have written this question, answer I'll discuss in the next class. You can start leaving, attempt your after class assessment.